Welcome to Preeminent Test Prep. Today is day 27 in our 90-day SAT prep series. Today we're going to be spending about 20 minutes in the math section and then about half an hour with the SAT reading section. So what we're going to be doing in the math section today is we're going to be going through problems 24 through 30 of SAT Practice Test 3. As I go through the problems, I'll be giving you my tips, tricks, advice, insights, and strategies as someone who's scored perfectly on the math section back-to-back times, really trying to give you insights into what you can do to be more efficient on the SAT math section, as well as the general knowledge you need to know in order to solve problems. And then when we switch over to the reading section, I'll be going through a passage today, and I'll be giving you my tips, tricks, advice, strategies, and all of that good stuff as far as how you can approach the reading section more efficiently, how you can really eliminate wrong answer choices, how you can hone in your strategies for different question types, and how you can do all of that, as well as tips for different passage types as well. But let's go ahead and get started with problem 24 in SAT Practice Test 3, and we'll get going from there. So we have Mr. Cole has a beaker containing n milliliters of solution to distribute to the students in his chemistry class. If he gives each student 3 milliliters of solution, he will have 5 milliliters left over. In order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. How many students are in the class? All right, well, it's going to be, okay, so we're going to set these two equations equal to each other. So how did I get these equations? Well, the first thing that I think you should put in your notes, if you're taking notes on this, is that as I read through this, I went ahead and I wrote my equation down, okay? So what I was writing down is anything that I saw as a relationship between variables. So I saw that we have, if he's giving each student 3 milliliters of solution, then 3 times his number of students, right? This is an S here, not a 5. Okay, that's an S, not a 5. 3 times his number of students, since he's giving 3 milliliters to each student, plus that 5 he's going to have left over is going to give him his total number of milliliters for that expression there. Then I saw that in order to give each student 4 milliliters of solution, so 4 times each student, he's going to need another 21. So the amount he has is 4s minus that 21 that he needs. Okay, so I set those two equal to each other since they're both going to be that total number of milliliters he has. And then I go ahead and solve then for my number of students, which I represented as s. Okay. Now, why did I pick S as my variable to represent students? Well, that's because it's the first letter in students. Okay, so one thing that you should get into the habit of doing is anytime you're given a variable like I was up here, in this case it was students, I saw it up here, I'm going to use that first letter of whatever that is. If it was workers, I'd use W. If it was teachers, I'd use T. If it was time, I'd use T. Anything like that, I'm going to use that first letter of whatever it is as my variable. I'm not going to pick X. And the reason why is because as you get into other problems, some of them will tell you they'll have A, B, C, D here, and they're going to have something such as 10S plus 80 W or something like that. And what those S and those W's will be is they'll end up being the first letter of whatever variable they represent. And that's really a commonality that you generally see on the SAT math section. It may not always happen, but in my opinion, I've really seen it happen most of the time. So that's what I would highly recommend you doing, because that's going to make it easier for you to match equations on other questions. So that's just a good habit to have. That's something you can put in your notes. All right, so back to solving for this problem after I gave you that topic or that hint to put in your notes. So in this case, we have our equation set up, right? Now we're just going to go ahead and solve for s. So what I'm going to do is I'm going to subtract 3s from each side. Why do I do that? Why did I pick to subtract 3s and not 4s? Well, I did that because I want to solve for s. And by subtracting that 3s, I'm keeping s positive, right? And I'm solving for s right away. I don't have negative s, I just have s. Okay, next I'm going to add 21 to each side because I have to set s equal to a constant. So 21 plus 5 is going to give me 26. I see s equals 26. I know s represents my number of students, so my number of students then will be D26 for question 24. All right, now we got question 25. Okay, so I've got a cubic silo. Okay, let me zoom out a little bit so you can see the whole thing. All right, so we've got this silo here. Okay, so we've got a grain silo is built from 2 right circular cones and a right circular cylinder with internal measurements represented in the figure above of the following, which is close to the volume of the grain silo in cubic feet. Okay, so one thing I want to talk about here. Okay, we know that we have to know the volume equation then for this cone here as well as for this right circular cylinder. We also have to know it for this cone down here, but that's going to be the same equation as this one up here. Okay, so one thing that you should know is that you are given these equations back, way back in your equation sheet that they give you for the SAT math section. But if you have to flip all those pages back and then flip all the way back here and then go back and find the other equation you need and then go all the way back, that's going to waste you time. So what I really recommend that you do is memorize the equations that they give you on that first page of the SAT math section, so that way you don't have to flip back and forth. Okay, because those are common equations that you're going to need to know to solve problems, and if you have to flip back and forth, you're going to waste a lot of time. Okay, so we know that the volume for this right circular cylinder is going to be pi r squared times our height, and we know that the volume for the cone is going to be 1/3 pi r squared times our height. Okay, now since we know that we have two of those cones, we're just going to multiply that volume by 2, and we don't even have to do another volume equals down here, because we know that it's going to be the same equation since they each have this 5-foot radius and this 5-foot height. So we're just going to multiply that by 2. Okay, so what we can do is we can take that 2 and just put it right here on top of that 1/3, right? So now we have 2/3 instead of 1/3. Okay, and I'm actually I'll rewrite it just because I want you to see that that's the volume equation there. Okay, so our total volume then is going to be this pi r squared times this height here, which is 10 feet, plus that 2/3 pi r squared times the height of our cone, which is going to be that 5 feet, so times 5 feet. We know our radius for each one is going to be that 5 feet, so we can go ahead and plug in 5 squared for that radius squared. We got 5 squared. Plug it in over here as well. We see we're going to have 5 squared times 5, so that's going to be 5 cubed over here. Our height we see is 10 for our cylinder, so we're going to have to multiply that by 10. Now at this point, we're going to have to grab a calculator because we're going to want to know what pi is exactly. So I'll go ahead and find my calculator real quick. Let's go ahead and do that. Alright, so I got my calculator out. Now I can go ahead and plug in. So I know 5 squared is 25. 25 times 10 times pi. And then I take that and I add that to 2/3 times pi times 5 cubed, which is going to be 125. And that's going to give me my answer of 1,000. So V is going to equal 1,047.2. So that's going to be answer choice D. Okay, so the big thing that you should really note as a strategy is that you should have these equations memorized. All of those equations on that first equation sheet that they give you on the SAT math section, you should memorize them so you don't have to waste time, okay? As someone who's scored perfectly at back-to-back on the SAT math section, I have all of those memorized, and you should too, because it's going to save you time from going back and forth. So especially if you're shooting for over a 600 on the math section, you should really be looking at memorizing all of those equations, because it's really going to help you save time, and it's a timed test, so you want to save as much time as you can. All right, so with that, we go ahead and move on to question 26. So we got in the xy plane, the line determined by the points 2k and k32 passes through the origin. Which of the following could be the value of k? All right, what I immediately look at when I have a pair of points like this, and I'm told that it passes through the origin, if you don't know, the origin is 0.00. Okay, so if you're going to want to put that in your notes if you don't know it, the origin is 0.00, is I'm going to look to find my slope. Okay, so if I'm looking at my slope, if I know my point passes through 0, 0, I've got to have this 0, 0 paired with this and paired with this, and then I can use my slopes to solve for k. So what I'm going to do here is I'm going to take that 0, right? I'll use my slope equation, which is my rise or my y, my difference in my y's over the difference in my x's. Okay, so that 2 as my final x minus my initial x of 0 is going to give me 2 in my denominator. And then my final y value is k minus my initial y value of 0 gives me k. Okay, so k over 2 is going to be my slope. Now I can also calculate my slope from this right here and pairing that with 0 and 0. So I'll go ahead and do that. I see my x value in this case is k, so we'll go ahead and call that k minus 0 in our denominator. Right, k minus 0 is going to give us k as our denominator. Up top we see that we have 32, so we're going to have 32 minus 0. Okay, another thing that you should note is how I picked what was going to be my first term and I kept it the same in my bottom and my top. Okay, you're going to get the wrong answer if you were to do 0 minus 32. Okay, why would you get the wrong answer? Well, you're going to deal with a negative up top when you should be dealing with a positive up top. So what you may want to do, this is something you can do, is you can call this, you could call this x2, and you could call this y2, and you could call this over here x1 and y1. But either way, you're going to want to keep those ones the same, right? So you're going to want to call that pair of points, you're going to want each of them to be the first one, and this pair of points over here, each one of them to be the second one. It doesn't matter which one's first, which one's second. It just matters that they're the same, right, for the pair of points. All right, so in this case, we're going to have 32 over k. So at this point, we know that both of those are going to be equal to our slope. So now what we can do is set them equal to each other and then solve for k. So we're going to have k over 2 is equal to 32 over k. We're going to multiply each side by k. Multiply each side by k. Then we're going to multiply each side by 2 to get rid of this 2. 32 times 2 is going to give us 64. K times k is going to give us k squared. So now we have k squared equals 64. Take the square root of k, take the square root of 64, and we know then that k is going to equal 8 because the square root of 64 is 8. So correct answer for the value of k is going to be C. Now one thing I want to bring up because I haven't brought it up yet, and if you've been watching these videos for a while, you know I talk about this a lot, but we always want to pay attention to what this end question is asking. In this case, it's the value of k, which we just solved for, so we're perfectly fine with C being our answer of 8. But we just want to always pay attention to that because sometimes it could ask you for the value of 2k plus 3 or something like that. Okay, so we always want to pay attention to what we're asked at the end. So that's one thing you can put in your notes there. The other thing would really just be making sure that we're paying attention to the word such as the origin, because if we didn't pay attention to this part here, it passing through the origin, we wouldn't be able to solve for this. So it's very important that we pay attention for that as well. So looking for details, especially on these later questions in the math section when it's more difficult, is very, very important. All right, 27. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations and decrease the area of the rectangle by 12%, what is the value of p? All right, well, one thing that you see that I did here is I went ahead and I wrote my equations out as I read through, right? So that's one thing I talked about earlier today. We'll talk about it again. I want to write my equations as I go through. So this right here is a 1.1L. I'll write that a little bit neater so you can see it better. Another thing with L's, I always write my L's like this so they don't look like a 1 so I don't confuse them. So that's one thing I recommend you do as well. With variables that look like something else, make sure you try to differentiate them. So if I'm using an L, I'm going to draw it like that instead of like that, because that could look like a 1. All right, so I saw that I have a 10% increase in my length, so I wrote 1.1 times whatever my initial length was. And then I saw that I'm decreasing my width by p%, right? So if I'm decreasing my width by p%, then that's going to be 100% minus whatever my p% is, right? And that's going to have to be in decimal form. So what I'm going to do is I'm going to write it as 1 minus p, right? And really what you can do here, in my opinion, the best way to do this is to just call something, we can just call this, we'll call it q, right? qw. And in this case, q doesn't necessarily mean much, right? It's really just a placeholder. But the reason I do that instead of doing 1 minus p or something like that is just because it's going to be easier to solve that way. Because if we can solve for what w is getting multiplied by, then we can just take 1, subtract whatever q is, and then solve for p. So that's really just going to be the way that I think it's easier to visualize this, in my opinion. So that's how I'm going to go ahead and do it. All right, so what I see here is I'm going to have 1.1 times L, right? And I know I have to solve for my area. My area is decreasing by 12%. So if my area goes down by 12%, I know my area is my length times my width, and I have to multiply that by 0.88 since that's a decrease of 12%. So I know I have 1.1L times whatever is times my width is going to give me that 0.88. So what I'm going to do here, I see that this could be rewritten as 1.1 QLW is equal to 0.88 LW. I see that my LWs are going to cancel, right? I divide each side by LW. They're going to cancel out. So now I'm going to have 0.88 equals 1.1 times Q. I divide each side by 1.1 to isolate Q. Now I plug this in my calculator. I'll go ahead and plug it in real quick. 0.88 divided by 1.1. I see that that's going to give me 0.8, right? So Q is going to equal 0.8. Okay, now that it means that I have a 20% decrease, right? So my correct answer there is going to be C for 27. So how do I know that that's a 20% decrease when Q is 0.8? Because I'm taking 0.8, multiplying it by my original width, which means that's a decrease of 20%. Okay, so that's going to be answer choice C there. So you see that if I was going to use that 1 minus p, right? If I was going to use 1 minus p, that would just get kind of, it's just going to add steps. So that's why I didn't do it, because it's going to add steps because you're going to have to go through, solve for p, then convert p into a percentage, and it's just a lot more work than finding what is multiplied by w and then seeing, oh, it's 0.8, that means a 20% decrease. So in my opinion, that's just an easier way to do it with some less steps. So you can take your pick on how you want to do it that way. In my opinion, that's the easier way to do it. But big tip for 27 is writing out our equation as we read through to avoid having to read through twice and waste time doing that. All right, 28, in planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population is 50,000, which of the following represents the engineer's estimate of the population of the city T years from now? Okay, well, this is going to be an equation where we have to list our starting value first, which is 50,000. We know we're decreasing by 10% every 20 years. So we're multiplying by 0.9 every 20 years. Okay, that's a decrease of 10%. So t is our years, okay, in years from now. So every 20 years is when we decrease by that 10%. So that t is going to have to equal 20 to have that 20 over 20 to keep that as a 1, okay? So that's what our equation is going to have to be there, and we see that that's answer choice D, so D will be our correct answer there. So this one right here is really just understanding how to set up that exponential growth or exponential decay question, okay? So this right here is an exponential decay because we're decreasing from our initial value. I talked about in week 1 how this equation is set up. We're going to have our initial value here. Then we're going to have whatever our change is going to be. So in this case, a decrease of 10%. And then our power is going to be when that change occurs, right? So we see that that's going to happen every 20 years is when we lose that 10%. So we need that t years set over 20, okay? So answer there is going to be D. So that one's really just understanding that exponential growth and decay equation. If you want to brush up on that, you can Google it if you want, or you can go back and rewatch one of my videos from week 1 where I talk about the math equations list. Either of those are good choices. All right, 29. We've got handedness, we got male, female, right, left, and then we got our totals. So I've got a lot of text here, but unfortunately, since my table is not filled in, I know I'm going to have to read it. The incomplete table above summarizes the number of left-handed and right-handed students by gender for the 8th grade students at Keisel Middle School. There are 5 times as many right-handed females as there are left-handed females. Okay, so 5 times as many right-handed females as left-handed females. And we see that there are 9 times as many right-handed males as left-handed males. So 9M versus M. If there's a total of 18 and then a total of 122, I already see that in my table, which of the following is closest to the probability a right-handed student selected at random is female. Okay, so I see I'm looking for probability. I have a right-hand student, so my total is going to be out of 122, probability that they're female. So I'm looking for the value of 5F over 122. That's going to get me my answer. So I got to solve for that somehow. Okay, so you saw that as I read through this, I filled in my table. That's something I'd recommend you do as well with the SAT math section. So when I read that there were 5 times as many right-hand female students as left-hand female students, I called my left-hand female students F, and I called the right-hand female students 5 times F, right? Because it's 5 times as many. I did that same thing with males, except males it was 9 times as many. All right, so now what we can do is go ahead and set up a system of equations to go ahead and solve for what F is, because that's what we need in order to solve for that probability. So we see that we're going to have F plus M is going to equal 18 because that's that column going down for the left. So F plus M is going to equal 18. And then we see we're going to have 5F plus 9M is going to equal that 122. So now what we're going to want to do is we're going to want to substitute in a value of F for M, right? So if we're going to rearrange our equation up top, we would have M equals 18 minus F, right? We'd subtract F from each side, and we'd see that M equals 18 minus F. So at that point, we'd plug that in for that 9M. So we're going to have 5F plus 9 times 18 minus F, and that's going to equal that 122. All right, so at that point, we multiply that 9 by 18, plug that into our calculator. I think that's 168 if I'm not mistaken, but I could definitely be wrong. It's 162, so 162. Okay, so I'm going to have 162. I know I'm going to have to subtract that from each side to get rid of it, right, because I want to set it equal to a constant. 122 minus 162, that's going to give me negative 40. I see I also am going to have to multiply my 9 by my negative f, so that's going to be 5f then minus that 9f, 5f minus 9f, that gives me negative 4f. So negative 4f equals 40, divide each side by negative 4, that gives me then that f is going to equal 10. So the number of female left-hand students will be 10. I know I have to multiply this 10, my number of female students, by 5, put it over 122, and then find it as a decimal. So that's going to be 50 over 122, and that's going to be 0.41. So that correct answer there is going to be A. That's our probability. All right, so the probability a right-hand student is female is going to be 0.41. So that one right there is not too bad. The big thing as far as that one, the big thing there, honestly, a lot of it was not being intimidated by all of these words, okay, and having an empty table. If you were willing to persevere and go through and solve it, the math behind it isn't too terribly difficult. It's actually not that rough of a problem from a mathematical perspective. It was really just you having to have the perseverance to see all of this text and be willing to go through it because you didn't have another choice. There was no shortcut around this. You had to read it in order to find those ratios, but once you did, the math behind it isn't really too bad at all. So that one there, it's really making sure that you're confident and not intimidated. So that's a big thing there. Don't be intimidated if there's a lot of text because the math behind it might not be too tough. Then after that was setting up ratios, which I talked about there, and then just solving for the probability. So that one's not too bad at all. Really just having to persevere there was all it was. All right, now with that, we got our last problem for the math section before we switch to the reading. So we got question 30. So in the equation above, B and C are constants. If B is C minus 1/2, so B equals C minus 1/2, which of the following is true? All right, well, in order to solve for this, I'm looking at my stacked equations here. And what I'm going to look to do is I'm going to look to get them equal to each other. That way I can solve for what that B, or what X is equal to, right? Because it's telling me immediately, since I look at my answer choices and they all say X is Y and then plus or minus something, that I have to solve for whatever X is, right? So if I want to solve for what X is, I want to get both of these equations up here equal to the same thing. So what I'm going to do there is I'm going to go ahead and I'm going to subtract 5X from each side and I'm going to subtract 5Y from each side. So when I do that, I'm going to have in my top equation 3X. I subtract 5X, that's going to give me negative 2X then. So negative 2X plus B. I know that B is equal to C minus 1/2. So that's going to be plus C minus 1/2, and that's going to equal negative 7, right? Because that's what I'm trying to do is get those negative 7s to both be what each equation is equal to. Then I'm going to have to subtract 5y from my bottom equation, so 3y minus 5y gives me negative 2y. Negative 2y plus c then is going to equal negative 7. So at this point, I see both my equations have plus c. They both equal negative 7. I see I have negative 2x, right? Well, what is x going to have to equal for these equations to be the same? Well, I need to get rid of this minus 1/2 because I don't have that in my bottom equation. So I want to get rid of it. So if I want to get rid of that, then x is going to have to be, we'll go ahead and write it down right now. We know there's going to have to be a y in for x, right? Because we have to have negative 2y from right here. So we know there's going to have to be a y there. And we know we have to have plus 1/2 to get rid of that minus 1/2. So negative 2 times what gives me plus 1/2? Well, that's going to be times negative 1/4. Okay, because when we take this negative 2, multiply it by negative 1/4, that's going to give us positive 2 over 4, which is positive 1/2. Positive 1/2 gets rid of this minus 1/2 here, right? Gets rid of that minus 1/2 there. And we'll be left then with negative 2y plus c equals negative 7 in both equations. So we know our correct answer then must be x is y minus 1/4. So that's going to be answer choice A. So that one also not too terrible. Overall, questions 24 through 30 of SAT practice test 3, in my opinion, aren't too tough at all. They're, in my opinion, a bit easier than some of the ones that I've seen on practice tests 5 through 10. They were released earlier, I do believe, than practice tests 5 through 10 were. I think 5 through 10 were released after number 3 was, so 5 through 10 might be a little bit more accurate as far as the difficulty in the later parts of the section. I don't know for sure though, so don't quote me on that, but that's just what I hypothesize. Alright, so with that, let's go ahead and switch over to the reading section for today. Alright, so for the reading section today, we're going to be going through one passage. It's going to be a science passage, so it's going to be questions 42 to 52 from SAT practice test 3. So I'll be spending about 25 minutes going through this passage to kind of give you an in-depth perspective on what I look for as a 1590 SAT scorer. So really trying to break things down for you as far as what I think is important as I make my initial read through, and then what types of what question types are present in this passage. So what kind of questions I'm dealing with, and then how my strategy works for each question type. Really what I'm looking for when I'm looking for evidence. How I can find my answer, how I can get rid of wrong answer choices, how ruthless I am in getting rid of wrong answer choices, really everything that you need to know for the SAT writing section. So really trying to give you that insight and strategy from high scores so that you can implement that on your own SAT and with your own SAT practice tests and on the SAT itself. So with that, we're going to go ahead and get started with the passage. So what I'm going to do is I'm going to make my initial read through as I would if I were doing the SAT reading section. So it's basically going to kind of be a little slowed down just because I'll be reading a little bit slower than what I would normally read, but I'll really be highlighting as I go through things that I would underline if I were reading this for the first time on an SAT. And then after I do that, I'll go back through, I'll tell you why I highlighted those things, which you would be underlining since you're using paper and pencil and can't use a highlighter. So I'll tell you why I highlighted those things as I made my read through, and then I'll get into the questions and all of that. So with that, let's go ahead and get started. So we have this passage is adopted from Richard J. Sharp and Eliza Hayden. honeybee colony collapse disorder is possibly caused by a dietary pyrethrum deficiency. Copyright 2009 by Elsevier Ltd. Colony collapse disorder is characterized by the disappearance of adult worker bees from hives. Honeybees are host to the pathogenic large ectoparasite mite virodestructor, mites. These mites feed on the bee hemolymph or blood and can kill bees directly or by increasing susceptibility to secondary infection with fungi, bacteria, or viruses. Little is known about the natural defenses that keep mite infections under control. Pyrethriums are a group of flowering plants which include Chrysanthemum, Cocinium, Chrysanthemum, Cinereifolium, Marshalli, and related species. These plants produce potent insecticides with anti-mite activity. The naturally occurring insecticides are known as pyrethriums. A synonym for the naturally occurring pyrethriums is pyrethrin, and synthetic analogus of pyrethriums are known as pyrethoids. In fact, human mite infestation known as scabies is treated with a topical pyrethrium cream. We suspect that bees of commercial bee colonies which are fed monocrops are nutritionally deficient. In particular, we postulate that the problem is a diet deficient in anti-mite toxins, pyrethriums, and possibly other nutrients which are inherent in such plants. Without at least intermittent feeding on the pyrethrum-producing plants, bee colonies are susceptible to mite infestations which can become fatal either directly or due to a secondary infection of immunocompromised or nutritionally deficient bees. This secondary infection can be viral, bacterial, or fungal and may be due to one or more pathogens. In addition, immunocompromised or nutritionally deficient bees may be further weakened when commercially produced insecticides are introduced into their hives by beekeepers in an effort to fight mite infestation. We further postulate that the proper dosage necessary to prevent mite infestation may be better left to the bees, who may seek out or avoid pyrethrum-containing plants depending on the amount necessary to defend against mites and the amount already consumed by the bees, which in higher doses could be potentially toxic to them. This hypothesis can be tested by a trial wherein a small number of commercial honeybee colonies are offered a number of pyrethrum-producing plants as well as typical bee food source such as clover, while controls are offered only the clover. Mites could be then introduced to each hive with note made as to the choice of the bees and the effects of the mite parasites on the experimental colonies versus control colonies. It might be beneficial to test wild-type honeybee colonies in this manner as well, in case there could be any genetic differences between them that affects the bees' preferences for pyrethrum-producing flowers. I believe that's the end of the passage. Let's just quick check down here, and we see it is. All right, so at this point, I'll give you an idea of why I highlighted the things that I did. Okay, so as always, whenever I have a passage, I'm going to always make sure I read this beginning part, right, this little introduction section. I'm always going to highlight or underline the authors, always going to highlight or underline the title. I'm always going to underline the copyright or the date when it was written. Okay, so the copyright, if I'm not given the date that it was written, I usually assume that that's right around the time it was written. So in this case, 2009. All right, I see that I have a colony collapse disorder. Okay, so anytime I'm given the definition of a key term, I always highlight that as well. Colony collapse disorder is characterized by the disappearance of adult worker bees from hives. So that's going to be an important context to know. Okay, the next thing, what did I have? Well, I had that mites kill bees directly or by increasing their susceptibility to secondary infection with fungi, bacteria, or viruses. Little is known about natural defenses that keep the mite infections under control. Okay, so what's this telling me? Well, this is really giving me context behind the death of these bees, right? These mites, they can kill them directly or by increasing susceptibility to secondary infections. So that's a key important point I need to know is the secondary infection point, not just directly, but also indirectly. Okay, the other big thing is how can they prevent this? Well, that's through natural defenses, but little is known about that. So that was also important in my mind. So with the science section, I always want to pay attention to things that are important to the passage. Okay, next, these plants produce potent insecticides with anti-mite activity. All right, well, if these mites are causing the death of bees, I want to pay attention to things that are going to be anti-mite. Okay, so in this case, plants that are producing these insecticides, these pyrethriums, those are the plants that I'm looking at with anti-mite activity. Next thing, we suspect that bees of commercial bee colonies, which are fed monocrops, are nutritionally deficient. Okay, why is this important? Well, this is important, right? And I highlighted it because it was important. Well, if they're nutritionally deficient in this, as a result of taking these monocrops, they're deficient in pyrethrum, then they're going to be more susceptible to these mite infections, right? And if they're more susceptible to mite infections, then they're going to die off faster. All right, so that's why I highlighted that. Then after that, it was really just a lot of explanation and evidence, so there wasn't much I was going to highlight there. Then I got over here, and I highlighted that we should also test wild-type honeybees, right, in that manner, because those genetic differences between them could affect their preference for pyrethrum producing flowers. Okay, so that was something added on to the end where we're talking about, it's basically talking a little bit about the so what question. So I talked about the a couple days ago, if you remember that. Anything that answers my so what question I want to highlight. In this case, it's not necessarily directly answering it, but since we're talking about it being applicable to more than one type of honeybee, that is kind of tying it into my so what. So in this case, we wanted to test it with the wild type honeybee to see if genetic differences have any role in that. Okay, so that's kind of attaching itself to the so what question there. So that's why I highlighted that. All right, so with that, we can go ahead and get into our questions now. So let's go down here. We got question 42. How do the words can, may, and could in the third paragraph help establish the tone of the paragraph? All right, so what's the question type here? Well, we see we're talking specifically about lines 19 to 41. Let's see if that's going to, I can't tell if it's messing it up on your screen. Right now, my pen isn't really showing up on mine. But we see it's how the words can, may, and could in the third paragraph. That's lines 14 through 41. So in this case, we're dealing with particularly lines, a certain set of lines. So that's going to be a little detail question. So little detail question. Right, so we're really talking about the details in those lines establish the tone of the paragraph. Well, let's go take a look at them. So it was 19 to 41. We suspect that the bees of commercial bee colonies, which are fed monocrops, are nutritionally deficient. We talk about how it can become fatal, right? We also use the word could. So by using the words could, can, may, suspect, all of that is establishing that tone of the paragraph, that they are tentative, right? That they don't know for sure, but that they do suspect, but they don't know for sure that their hypothesis is correct. So that's going to be answer choice C for 42, right? They're not totally sure that their hypothesis is correct, but they suspect that it is. That's them using those can, may, and could. As far as A, they create an optimistic tone. Well, they're not optimistic if they're saying can, may, or could. That makes clear. All right, hang on. My pen is not working here. I'm going to try to fix this real quick. Just give me a minute. See if I can zoom out and see if that fixes it. Okay, that looks like it fixed it. So I'm going to stay zoomed out for a bit because my pen wasn't working when I was zoomed in. All right, so they create an optimistic tone that makes clear the authors are hopeful about the effects of the research on the colony collapse disorder. Okay, it never says they're hopeful or optimistic, so we can get rid of A. And even if the passage did, these words aren't indicating that. So that's the key part here is we want to pay attention to these words here. They don't create a dubious tone, and they don't make it clear that the authors don't have confidence in the usefulness of the research, because they do feel confident in that research. They just don't know for sure. That's why they're using words can, may, and could. They feel confident, but they don't know for sure. D, they create a critical tone that makes clear the authors are skeptical of claims that pyrethrum are inherent in monocrops. Well, that's kind of off topic, right? And it's not necessarily off topic, I take that back, but it's just not really applicable to our big picture in any way, or even our little detail here, right? Our little detail is really in the sense of a big paragraph, okay? And this paragraph's about more than monocrops. The other thing is it's saying that they're skeptical of claims. They're not skeptical, okay? They suspect that they're correct. They're not skeptical. They suspect they're correct, but they just can't prove it yet, right? They don't know for sure if their hypothesis is correct yet. So 42, the answer there is going to be C. All right, question 43. So we have in line 42, the author states a certain hypothesis can be tested by a trial. Based on the passage, which of the following is a hypothesis the author suggested be tested in a trial? Okay, so this is specific to line 42. This is most certainly a little detailed question, right? Anytime we see that we're referred to one single line, and it's not a most nearly means question or a words in context question, it's probably going to be a little detailed question. All right, so in this case, we're asked about line 42. So let's go ahead and take a look there. All right, so line 40, or it might have been 41. So we have this hypothesis can be tested by a trial wherein a small number of commercial honeybee colonies are offered a number of pyrethrum-producing plants, as well as a typical bee food source such as clover, while controls are offered only the clover. Okay, so that clover does not contain that pyrethrum, and those other ones do. So we're really looking at the difference between honeybees that eat that pyrethrum and those that don't. Okay, and what's the big point of that? Well, the big point of the eating pyrethrum versus not eating pyrethrum is the resistance to those mite infections, right? We talk about pyrethrum helping increase resistance to those mite infections or fighting off mite infections. So we're talking about whether a honeybee diet that includes that pyrethrum will result in honeybee colonies that are more resistant to those mite infections, right? So we're comparing those with the pyrethrum versus the controls that take that clover, which does not have it. As far as A, we'll go ahead and explain why A is incorrect. A says honeybees are exposed to both pyrethrum and mites are likely to develop a secondary infection by a virus. Well, if we're exposed to pyrethrum and mites, those pyrethrum are going to help fight those mites off. They might not fight them off for sure, but this is not the trial that we're talking about. We don't talk about a trial in which they get both mites and pyrethrum. B, beekeepers who feed their honeybee colonies a diet of a single crop need to increase the use of insecticides. No, we actually talk about how insecticides can make things worse for those weak honeybees that are already weak from those mites. D, humans are more susceptible to mites. We don't ever talk about doing any studies on humans, so we can get rid of D. All right, so the next question is evidence. So let's go ahead and find our evidence for that. So if we're really talking about the honeybee diet, including pyrethriums, making them more resistant to mite infections, then we're really going to be looking for a spot where we talk about those mite infections and that relationship to pyrethrium. So we know that that's really right around here where we say without at least intermittent feeding on pyrethrium producing plants, bee colonies are susceptible to mite infestations, which can become fatal either directly or due to a secondary infection. All right, so we see that that goes up to 28 and that it starts at 24. So that would be our evidence there because we talk about how eating that pyrethrium, right, makes us less susceptible to mite infections, right? So we have to have that pyrethrium to increase our ability to fight off those mite infections. That's 24 to 28. So that's going to be answer choice D there. That's supporting our claim that that honeybee diet that includes pyrethrium may result in honeybee colonies being more resistant. All right, so as far as question types, I'll go ahead and cover that real quick. 44 is just an evidence question, right? That's all the question type is for that one. 45, the passage most strongly suggests that the beekeeper attempts to fight mite infestations with commercially produced insecticides have what unintentional effect? Well, I already talked about this a little bit, right? We talked about how that's going to further harm the health of those bees, right? And our next question is evidence, so I can actually go ahead and find that for you as well. We see, I believe it was back towards this middle part down here, right here. In addition, immunocompromised or nutritionally deficient bees may be further weakened when commercially produced insecticides are introduced into their hives by beekeepers in an effort to fight mite infestation. So the key part here is that nutritionally deficient bees may be further weakened when they are exposed to these insecticides, okay? So that's our evidence there. That's 31 through 35. Let's see if we have that as an answer choice, and we see that we do. So that's going to be answer choice C for 46. Right, that's showing us how it's going to further harm that health of those bees. All right, so as far as question types, 46 is obviously an evidence question type, right, because we're just providing evidence for our previous question. 45, so the passage most strongly suggests beekeepers' attempts to fight mite infestations with commercially produced insecticides have what unintentional effect? Anytime I see strongly suggests, right, that's kind of telling me that it's either an inference question or it's a little detail question. And sometimes those two cross over a little bit, like in this case, understanding that little detail that we talked about, how it can further increase or further harm their health. That's kind of a little detail that also allows us to make this big suggestion that they make in the passage, right? The passage is suggesting or kind of inferring that that's going to happen, right? They really hint towards that. That's kind of a little detail. I would say it's more of a little detail question than an inference question, but it's a little bit of both in a sense, but I would say more so a little detail question, less so inference question, because it is so strongly supported with evidence there. All right, 47, he's using line 35, postulate most nearly means. Okay, this is a most nearly means question, which means we're talking about words in context. So postulate, that's in line 35. Let's go ahead and go there, and let's come up with our own answer choice first. All right, so we further postulate, we see that's right here, we further postulate that the proper dosage necessary to prevent mite infestation may be better left to the bees who may seek out or avoid pyrethrium-containing plants. All right, so in this case, they're really postulating or hypothesizing, okay? So I would say hypothesizing would be good there, or putting forth an idea, hypothesizing, putting forth an idea, putting forth a claim, making a claim. All right, so making a claim, hypothesizing, or putting forth an idea would be great options there. All right, so we don't have hypothesizing. We have A, make an unfounded assumption. No. B, put forth an idea or claim. Yes, right? I said make a claim, put forth an idea. We see that is there. That'll be our answer there. So 47 is going to be B. They're not questioning a belief by postulating or concluding based on firm evidence because they don't have that firm evidence yet. All right, now we've got 48. 47 is a words in context question. 48 is going to be the main purpose of the fourth paragraph. All right, so this is a purpose question, right? Asking us about the purpose of a little detail. So purpose of a little detail. In this case, that little detail is about 8 lines. We want to know the purpose of including those details in those 8 lines. So what's the purpose of that? All right, so that's 42 to 50. We're going to go find that real quick. That purpose, we're really describing our experiment in these lines, right? We talk about how we're going to have controls with clover. We're going to offer these bees pyrethrium-producing plants as well as clover. Talking about mites, right, and how we're going to introduce them into the population and note their effect. So really touching on that experimental design there. So I'm going to look for an answer choice that has that. So A says summarizing the results of an experiment that confirmed the hypothesis. We don't have the results yet. We're just describing the setup. So for 48, A is going to be incorrect for 48. B, proposing an experiment. Yes, we do that to investigate how different diets, right, clover versus pyrethrum, affect commercial bee colonies' susceptibility to mite infestations. Yes, we said we'd measure the effect on their susceptibility to mite infestations. So B would be our correct answer for 48. As far as C, providing a comparative nutritional analysis of the honey produced, we're not tracking the honey produced and what nutrition it has, so C is incorrect. D, predicting the most likely outcome of an unfinished experiment. We're not predicting the likely outcome of it, we're just describing its setup there. So that's why D is incorrect. 49, an unstated assumption made by the authors about clover is that the plants, A, that's going to be do not produce pyrethrum. So how did I know that so fast? Well, if we're going to use clover as a control, which we say that we do, and I'll go ahead and show you up here, I'm going to erase some of this underlining so you can see it better, right? All right, so we have, they're going to be offered a number of pyrethrum producing plants as well as a typical bee food source such as clover, okay? So if we're going to use that control being offered, only the clover, if that control is going to be the clover, then it can't have pyrethrum because then it isn't a control, okay? So that clover cannot have pyrethrum in it. Also, I think I'm saying pyrethrum wrong this whole time, but I don't need to know how to pronounce it, so if I'm saying it wrong, that's okay. All right, B, are members of the chrysanthemum genus? No, we don't make that claim. C, are usually located near wild type honeybee colonies? We don't make that claim either. D, will not be a good food source for honeybees? We also don't make that claim. All right, 50, based on the data in the table, what % of colonies with colony collapse disorder were the honeybees infected by all 4 pathogens? So this one is just interpreting the table. So we got colonies with colony collapse disorder, which is what we're told our column was going to be. And then we're asked about those with all 4 pathogens, and we see that that's 77%. So I believe that that was answer choice B, and it is. So that's going to be answer choice B for 50. So B for 50, that's going to be 77%. That one was really just interpreting data, so I'll call that interpreting data, interpreting data. That's question type right there. I think I forgot to say question type for 49 and 48, so I'll just, okay, got 48, 49. An unstated assumption made by the authors about the plants is what? This one's really testing your ability to make an inference kind of that's supported by data, right? So it's a little bit of a little detail and inference question mixed together, right? So it's not stated directly, but we can infer that assumption from the passage. So we're going to use evidence to make an unstated assumption, right? We're going to infer about what that unstated assumption is based on the evidence, based on the text. Okay, so based on those little details contained in the text, what's this unstated assumption? Well, based on them saying that they're going to use the clover as control, that unstated assumption has to be that they don't produce pyrethrum. All right, now we got question 51. Based on the data in the table, so once again, this is going to be interpreting data, which of the 4 pathogens infected the highest percentage of honeybee colonies without colony collapse disorder? Okay, so this is going to be our other column, those without colony collapse disorder, and we're looking for which one infected the highest percent. We see that that's at this 81, that's the highest number there, so that's going to be Nosema ceranae. Nosema ceranae. Let's see if that's an option. We got 51. Okay, we see that that's going to be option D, Nosema ceranae. That was the one that infected the most, highest percentage, okay? So that one's just interpreting data, so that one's not too bad at all. So you see with the science sections, interpreting data shows up a fair amount, right? We just had 2 of those. Anytime you got a table or something like that, you're probably going to have to be able to interpret it. So that's why interpreting data is important with the SAT reading and the writing sections, because you still have to be able to do it there. Now you'll notice that you also get practice interpreting data with the SAT math section, so you'll get practice with it in that section as well. So as long as you're prepping for the SAT for a while, you'll get better at interpreting data, so don't worry too much if you're struggling a little bit right now, because we'll still keep working with that over the next 60 or 70 days, however long we got left. All right, 52. Does the data in the table provide support for the author's claim that infection with vero mites increases a honeybee's susceptibility to secondary infections? All right, well, our table, it never says which group is infected with vero mites. Okay, so we can't make a claim about that because our table doesn't say it. And if we go back to our table, I can show you how it doesn't say it. None of these groups does it say has the vero mites. Okay, they have colony collapse disorder, and they don't have colony collapse disorder, but it doesn't say anything about having vero mites. Okay, here we have pathogens which aren't vero mites, and here we have fungi, none of which are vero mites. So we can't make any claim about vero mites from that table. So the answer is definitely not going to be yes, so we can get rid of A and B. As far as C, no, because the data doesn't provide evidence about bacteria as a cause of colony collapse disorder. No, that's not why. D, no, because the data doesn't indicate whether the honeybees had been infected with the mites. Yes, we don't know if they have them or not. So 52, our answer there is going to have to be D because we just don't know if they have the mites or they don't have them. Okay, if we don't know that, we can't say that they do or we can't say that they don't. We just have to say we don't know whether they have them. Okay, so it doesn't indicate whether they got them or not. We can't say they for sure don't have them, but we can't say that they for sure do either. So the answer there is going to be D. All right, so hopefully that was helpful. If it was, there's going to be a donation link in the description when it's up and running. Any private SAT tutoring I'm doing will be linked in the description. Any private college admissions consulting I'm doing will be linked in the description. As always, make sure to like, share, and subscribe, and make sure to have a good day.